So here's problem number 29 from the chapter 3 review. Let's see if I can remember the rule that'll help us do this. I want to remember that the derivative with respect to x of inverse cosecant u is equal to negative because it's a co. And then I have to remember the secant version, which is absolute u square root of u squared minus 1 du dx. Now in this case, what is u? Secant x. So I'll go to my formula, and wherever I would have seen a u, I'll put in secant x. And then I got to finish off with a chain rule. The derivative of secant is secant tangent. And what do we end up with at the end? If I clean this up, negative secant tangent over the absolute value of secant x secant squared x minus 1.
But the absolute value doesn't matter because it's
Yeah, I think this is little mama.
No, it's
Can I just double check? I know that sine squared x plus cosine squared x. Okay, but if I divide everything by cosine squared, if I divide all of this by cosine squared, I end up getting secant squared over here is equal to 1 plus tangent squared. If I subtract both sides by 1, I get that tangent squared x is equal to secant squared x minus 1. So this thing right here is equivalent to the square root of tangent squared. Okay, now let's talk about the secant and the absolute value of secant thing going on there. Can we do that for a sec? Okay, on this particular range of values for x, is secant always positive? No. Secant, and this is like pi over 2, and this is 3 pi over 2, and secant goes like this, and then like that, and like this. So no, it's not always positive, and it's not always negative. So can I just simply strip off those absolute value signs? No, I can't. I cannot. I can do what with the tangent? I can almost cross it off. This is one of the most sneaky problems I've seen out of our book. Okay, watch this. Okay, officially, when I do the square root of tan squared, guess what I get?
Plus or minus?
I do not get plus or minus. Think of a number. Think of a number from 1 to 10.
2.
6. Square it. 36. Take the square root of that. Oh, I got 6. Okay, now choose a number between negative 10 and 1.
Negative 7.
Negative 7. Square it. Take the square root of that.
7.
Oh my God. So the act of taking the square root of a square produces a something that's always positive, which is another way of saying that it's an absolute value.
Look at that. That's insane.
Okay, so now, hold on. So what's the ultimate reaction to all of this? Okay, is that Secant.
Okay.
Well,
Tangent equals
hold on.
1
Let me.
over
Can I?
cosine, and tangent equals
Can I pull out in front?
sure.
Yeah.
And so I get 1 over cosine on top,
Times
multiplied by
sine over cosine,
sine over cosine,
all
all over the absolute value of 1 over cosine
times sine over.
times the absolute value of sine over cosine.
And then because the cosines go down, and then that goes up.
Okay. So if you work this out, it's pretty clear that the thing on top and the thing on bottom are going to be exactly the same, except for the sign. Sign S-I-G-N, not the S-I-N-E. The sign. These are gonna. This is gonna be the same as what's on the bottom, but this may be negative. This is always going to be positive. All right. Now, one more step we can kind of deal with here. Sine over cosine squared over the absolute. Sorry, lost my negative sign. Over the absolute value of sine over cosine squared. Wait, cosine squared is always positive. Can I pull that out of the? Can I pull that out of the absolute value? So we get sine over cosine squared over the absolute value of sine over cosine squared, and we can get rid of the cosine squared. So we're left with negative of sine over the absolute value of sine. Now I think
Is this a test question?
this is
It's a nightmare.
well, it brings up a lot of ideas. Okay, let's just go. What could be? I think I got to resolve to what their final answer is.
That's it.
Is that what they say? What the final answer is?
But there's more.
They put some
Okay, hold on. Let me. I thought the answer was the opposite of the sine of sine.
Yeah.
Well, then it moves it to that. So first it says this.
It has an intermediate step from here to there.
Yeah.
It says what we just got, and then it goes to that equals negative.
Oh, okay. Okay. These are equivalent. All right. So here's. Okay. Again, we got all these restrictions because of these absolute value signs. All these absolute value operations. Here's the idea. This value here is either 1 or negative 1. No matter what value I put in here, either I'm going to get the same.
Plus or minus 1.
So the answer is essentially either 1 or negative 1. And the question is, when is it going to be 1? When is it going to be negative 1? One way to write this is that when sine is positive, this expression produces a negative 1. When sine is positive, this expression here produces a negative 1. Well, when is sine positive on this particular interval? From 0
From 0 to 5.
to pi.
Yeah.
Wait, hold on. Oh, and it's actually we can't. It's undefined. It's undefined at zeros. All right. And then when sine is negative, this thing produces a positive. So from pi to 2 pi.
But you can touch it at 0 and 2 pi the both of
Is this?
I don't know.
No, I don't think so. Because secant is not defined at.
Just tell us we'll never have to do something like that.
We will have to, though.
You'll never have to. No, this is a very challenging problem. I'm unlikely to give you a problem of this complexity on a test.
All the AC test is-
Okay, but you have to understand, all that is important is not testable, and everything that's testable is not important.
Could you repeat that?
It means that regardless of the fact that I probably couldn't put this on the test because it's too long and complex for a timed test, it doesn't mean that these kinds of ideas aren't important. All right, so let's call this one done. 29 done.